Hello, this is EE201 final project, and this is analog to digital converter circuit for our part 1. So we used two power supplies in order to implement this circuit. This one is for our op-amps and this one is for our reference voltage and V-in voltage. We used minus 16 volts for our minus VCC and plus 16 volts for plus VCC. Our reference voltage is 5 volts and our V-in value will change during the experiment.
Let's continue with our power cables where they are connected in our circuit. We put our V reference in here and this V reference connected to our 16 1K resistor, and each 1K resistor we put jumper cables, and these jumper cables connected to our inverting part of our op amps, and for our non-inverting part we put V-in voltage. We put our VCC plus in here and this one jump over there. Our minus VCC voltage is come from in here and this cable jump over there. We connect our output to our 1K resistors in here, and the resistors another leg connected to our LEDs, which they are grounded, as you can see. Let's give output to our circuit. Let's start. As you can see, our LEDs are turned on consecutively. Let's get into details more. As you can see, our first LED is turned on at 0.4 volt. Our second LED is turned on at 0.7 volt. Our third LED is turned on at 1 volt. Third LED is turned on 1.3 volt. 1.6 volt, 1.9 volt, 2.2 volt, 2.5 volt, 2.8 volt, 3.2 volt, 3.5 volt, 3.8 volt, 4.1 volt, 4.5 volt, 4.8 volt. That's it for our first analog to digital converter circuit.
This is part 2 of our EE201 final project. The circuit we are seeing right now is the digital to analog converter circuit. So we use two power supplies to implement our circuit. This one is for our op-amps and the second one is for feeding our circuit. As you can see, op-amps VCC plus is plus 10 volts and minus VCC is minus 10 volts. And 5 volts. And this second DC power supply is giving us minus 5 volts to feed our circuit. Now let's analyze our circuit. Here you can see our common ground, and our common ground is going right there, here. This red cable is plus VCC and this yellow cable is our minus VCC, and lastly this cable gives us our minus 5 volts. So our ground cable is grounding our first 2K resistor, which we obtained by connecting two 1K ohm resistors. Also, this ground cable connection grounds our op-amps non-inverting leg, as you can see. We used 5 2K resistors by connecting two 1K ohm resistors in series, as you can see here, and four of them, this one, this one, this one, and this one, are connected to four different switches, which we are going to use them for giving different binary numbers and obtaining analog signals. For example, if you want to give 1000 to our circuit to obtain an analog signal, we should open our first switch, which is opened right now, and the rest of the three switches should be closed so that we can read a 1000 value from the multimeter, which we will use later. The switches are connected to each other by 1K ohm resistors, as you can see here, and last 1K ohm resistor is coming from the inverting leg of op amp to the output leg of our op amp. Now we will use a multimeter to see the conversion of digital values to the analog values. Right now all switches are closed. That's why we are reading the value of 0 in the multimeter. Let's give 1000 to our circuit and try to read the value of the analog value of it. As you can see, it is 2.41. Now let's try 1001. It's approximately 3 volts. Now let's try 1011, which is approximately 3.6 volts.
Hi, today I will show DTMF keypad design. I use for 1K resistor, and this resistor is reference resistors. This is our buzzers, op amp, and our button. That's two red cable is came from function generator. This cable is positive side. It came from for this resistor and that resistor, and we give the op amp positive 15 volt and minus 15 volt. Our system is working right now. We give 1.209 kilohertz and 679 hertz. This is for number 1, and this is the sinus waveform on the output voltage. And this is our frequency, and this one is peak 1, and this is the peak 2.
This is the electrical system design of a living room. This is our power supply, and it comes to current leakage fuse. Our output phase coming back to the fuses, and we are doing a phase bridge to the fuses, and our neutral comes to the neutral bus. All the neutrals from the objects coming that bus. The 16 ampere fuse is opened now. It comes to the lights. It comes commutator first, and then it goes to bulbs. Their neutral comes to the neutral bus. This is the connection of commutator. The second is 20 ampere fuse, and it goes to the plugs. Now the fuse is closed, so the plug is not working. When we open the fuse, the plug is working now. For the third fuse, this is our air conditioner. This is the image of an air conditioner. When we close the current leakage fuse, the system is closing.